Hello everyone, this is yet another episode of Career Talks by Welcome Solutions, and in these meetings we talk with professionals with interesting career paths who share their life hacks with us. And if you would like to support this channel, please leave a thumb up and subscribe, that always helps. And today I have great pleasure to introduce Caolan Kovach-Orr, Ph.D. He has a proven track record in team management, including new and existing hires, predictive modeling, creating actionable insights, team management, feature engineering, data manipulation and cleansing, new product creation, and research and development in academia and industry. Great to meet you, Caolan. Thank you so much for visiting us today. And great to have you. And I would like to, I'm very curious about your whole story, told from your own perspective and all the things that we cannot see at your LinkedIn profile.
Well, I'm really happy to be here and thank you for having me. Yeah, so I guess it would make sense to go back to kind of the beginning, which was back in college. It's kind of funny. I really didn't want to have an office job, and I take this from an office right now. And so I got drawn towards ecology and natural resource management, thinking that I was going to be a field researcher. And then once I got into the field, I realized I was pretty good at math and like the comp sci side of everything. And so I kind of naturally gravitated towards that.
In Welcome Solutions, we help highly educated professionals with navigating towards their dream careers. We offer intensive career rotation courses combining self-discovery with practical information about the job market. We also work on our own educational materials such as books and self-navigation manuals. Our new tool, the Odyssey test, will help you discover what your natural way of creating value in the job market is and which working environment will fit you best. If you'd like to stay in touch with us and receive monthly updates, please subscribe to the newsletter.
In my undergrad, a few very instrumental professors helped me kind of navigate the grad school pathway and kind of push me into academia, which I think at the time was absolutely the right pathway for me. And they're tremendous help. And so then I went to McGill and worked on my Ph.D. under Gregor Fussman. And, for probably the first half of that, maybe a little bit more, I was dead set on becoming a research professor at some large research institution. And somewhere around halfway through, I just became a little bit disillusioned with the career paths that were available to researchers. I mean, you wind up in a situation where you're years away from any type of job security. You're grossly undercompensated for your skill level and grossly overworked throughout, a lot of your PhD, then your postdoc, and then your pre-tenure professorship. And so I started thinking about leaving academia and going to industry. And so, there were a lot of different conversations I had, both with my supervisor, people outside, and it was kind of a tough transition and tough decision to make emotionally, because it had been something I'd been planning on for, maybe 6 or 7 years at that point. But, when you think about how old I was back then, that was a huge chunk of my life and almost my entire adult life. But eventually I decided for sure to leave academia, with maybe the intention of one day returning. But, I think that was just wishful thinking or something like that. And so I started applying for jobs after I defended my thesis in 2015. And I kind of got a lucky break with my current employer, Verisk, in that there was this position that was really well suited for me. And somebody had taken the offer for it, but then withdrawn with only a couple months or a couple weeks to go before the start date. So I kind of snuck in with them trying to fill a position and me being the only available candidate. So it was the situation where I was either going to get hired or they were just not going to hire anybody, which I'm very fortunate for, because I took the job when they offered it and have had a pretty interesting career here for the last 6 years. So some of the highlights along the way were, let's see what happened. I've been here for about a year, and everyone in my division quit to follow the then leader, our SVP Glenn, to another company. And so it was just me and the AVP and one other person left in the division. And so there was a lot of opportunity there. It was a little stressful, but I saw that like, 10 or 15 people leave all at once. All of a sudden I become the person with the most institutional knowledge or whatever. And so I stuck around through that. And then kind of turned into a high intensity mode for a couple of months where we were trying to build this product using a GLM, for commercial auto rate making purposes, pricing of insurance. And it didn't work. And I was pretty sad. And I went back and I started to use some machine learning algorithms on the same data set, even though everybody said that we would never get it approved by regulators. And so that kind of kicked off this whole thing, because once we started using machine learning, we had to start using like cloud computing and Spark and Hadoop. And so kind of in one long but continuous swoop, I built out a really predictive model using machine learning, and also built the AWS infrastructure that my division still uses today. Mm-hmm. And then it took only a couple months to build the algorithm for the new pricing model, but then another maybe 6 months of just building out interpretation so that we could explain it to regulators and get it approved, and then maybe another 9 months to actually get it approved. And by that point, I started building out a team focused on data engineering and data science and new technologies. So specifically to kind of push the envelope on things like machine learning for rating purposes, or infrastructure, like big cluster computing, like Spark clusters and whatnot, GPU and FPGA, accelerators, that kind of thing. And so it's been a really interesting time. So that team started, I hired 2 people, and then we opened an office in Poland, and I hired 4 or 5 more, and now we're up to 17. And it's been a really exciting time. And just a couple weeks ago, I accepted an offer to lead Hippo's risk data science group, so Hippo Insurance, and that'll be starting in a week and a half. So it's interesting, and I think one of the things that I've been thinking about a lot lately is that I've spent all this time kind of building up this team, hiring these people out and training them, and obviously people are a little bit nervous with my departure, but trying to explain that my departure is actually probably a good thing for all of them is a hard thing to do, but it's the truth, because it's the same way I wound up in my position, is that other people left, and then that creates a vacuum, and you fill it, or they can fill it in a way that's unique and special to them, right? Like nobody's going to replace me in the same way that I'm not replacing the people before me. I'm bringing my own skills and perspective to the need of the division, and other people will have other skills and perspectives and strengths and weaknesses, and that's okay and even good, because if it's just one person kind of directing a team forever, it tends to get a little pigeonholed or staled. At least, at my level, obviously, as you go higher up, you want definitely much more stability in senior leaders. But, for relatively moderate sized teams, it's good to have some changeover.
Right. Well, actually, this is a good way, like of getting promoted or getting to important positions in the company. Just wait, like outlast everybody else. Just wait until everyone else goes. But it happens. It happens relatively often in small companies and in startups, because there is a high turnover. Like everything is still
in the making, and it can happen that you become a head of a department just because everyone else is rotating and you stayed for 2 years or more, and that's the only reason. So actually, my first question would be, since you studied biology and your research was in biology, from what I understood, how does it help you today? Since today, from what I understood, you are doing mostly like hardcore machine learning like models. So what was this transition? How did you make a transition from biology towards machine learning? Because like there is still a stereotype that to do AI and machine learning, you have to have like very like hardcore technical background. So how did you learn about machine learning? And do you think that every biologist can handle it, or did you have some special training somewhere early in the process? And what was your path?
Yeah, so I think one of the interesting things is that when people find out I was a biologist, they assume I was working, like a wet lab with, cells and DNA or something like that. I was a mathematical biologist, so I was working not on the statistical machine learning side of mathematics, but on the different, like deterministic modeling side. So ordinary differential equations, partial differential equations, and massively parallel simulations of bifurcation and continuation of these complex, but five equations. These family, these systems of complex equations.
Actually,
and so,
then we could have a lot of common topics, because actually I published a few papers in applied mathematics based on delayed differential equations, and I was
cool.
I was modeling like all kinds of things. Actually, I was modeling, this, because in today's mathematics, it's often the case that mathematicians, they just specialize in one type of equation, and they, given how the granting system works, you basically specialize in one type of models or equations, and you try to force them into as many biological systems as possible to write as many proposals as possible. So you were basically using the same like kind of methodology to research all kinds of things we could come up with, which was anything from interpersonal, like this is the science the wrong way, of course, what I'm saying right now, but I'm confessing here. It's my confession. I was doing science the wrong way. And we were trying like everything with these equations, everything from modeling interpersonal interactions to modeling some networks in the visual cortex. So everything where we could find a system where you have some local inhibition. So you have, because then this is what you need for oscillations. You have to have a system where you have excitation one way and inhibition the other way around, and you have some delay in the interactions, and then this is what generates cycles. So so yeah, that kind of systems. But I think I could, maybe I should check out your publications, because I have a gut feeling I might actually understand what you were doing. Maybe it would be interesting for me. But that was just a digression. Okay, so I get it now. So you have actually a background in mathematics, and you could program before you started working in industry. Okay.
Yeah, and kind of to that point, so I think you were asking two things, which is how did I get to where I am given my background? And, at McGill and a lot of other Canadian universities, as well as many universities around the world, the graduate work isn't almost entirely based on research. So I think I took 2 courses my first year of grad school, and that was it. And so everything after that was self-taught. And so while I had some background in mathematics and GIS and computers from undergrad, it was not like to a very high formal degree. So it was a lot of reading and learning and trial and error, right? So there seems to be some some trend in the market for people to write data science blogs in order to do some type of self-promotion or, try to build up their resume so they seem like some sort of leader. And there are good ones out there. There are people who write mathematically sound advice and instructions. But what we often see is that people tend to extrapolate general trends from these kind of very specific scenarios, or maybe they had, I could still remember, I was thinking about this last night. I was in a bar a couple of years ago, and these guys had just graduated from a master's in data science from one of the universities in New York. I won't name it, but one of the very good ones. And they were talking about how their new employers use window machines, and that their new employer is they're I think the exact words were, they were idiots. They're using Windows for data science. They should be using Mac. And these kind of ideas that like you have to do it one way, or that everything after, I don't know, 2 months or a year, I think are very detrimental to data science, because the big thing about data science is that it's both comp sci and science. Like it's truly the science part that's important to becoming a good data scientist. And I think that gets often overlooked. So people think like, oh, I can build an XGBoost model, I'm the best data scientist out there. And there's just a lot more to it than that. Right. There's a lot of nuance and complexity to what actually works well.
Mm-hmm. Yeah. Actually, this is important subject what you touched right now, because it's not only that professionals publish about data science today to get popular, but I think they often feel compelled to do so, because you have to become somewhat visible online, especially if you're freelancing, or if you feel like you're a beginner in your field, you have to build your name. And I think it becomes more of a standard today that even if you're employed in a company, you still have to take care of your image, online image. Yeah. So have your personal website, have a well-kept LinkedIn profile, have some activity online, have some discussion going on. And this is so we kind of become one single-handedly become companies, our own managers. And this is, I think, the trend that will progress. So the job market is becoming more and more of a soup, and we become more and more mobile and become more and more independent, which is kind of counterintuitive, because at the same time we want to belong, and we are becoming a part of all these different tribes, online and offline. But it's like two processes going on at a time. So at the same time, we want to be acknowledged as us personally. So we kind of also feel that we have to do it, even if we kind of have, this is a part of professional development. So I think this is a part of this phenomenon, that it kind of becomes a default. And I think another part of the problem is that for companies, especially for businesses, it's very important to get organic traffic. And for organic traffic, you have to have content, you have to have SEO. And it's actually, even there was some research on this, and showed that companies that have a blog on the website sell on average 60% more merchandise than companies that don't. And this is because of organic traffic from Google. That's why today companies, I'm kind of lucky because I'm a content creator myself, so I can write my own blog. But otherwise, if I didn't have those writing skills, I would be in trouble, because then your company website is invisible to Google machines. And every single time you want to attract anyone to your website, you have to pay for Google ads. And this is sometimes few dollars for one click. So this is incredible expense. That's why today, pretty much every company that is active in consultancy, let's say in machine learning and AI, they no longer have a choice to be visible to potential clients. They have to invest in content. And that's why there is such an abundance of content today. So it's a bit of kind of forced by the rules of capitalism that you have to do it. And actually, I have to say that last year we had a guest, Ali Kamnoyan, here at the channel. He has a little business based in Eindhoven, here in the Netherlands. He's fantastic. He's a very good content creator. He writes, I can see his content on LinkedIn. So I will link it here below. So if you are looking for good content in machine learning, then he's posting very good and very informational, also educational materials that explain to broader audience how all these algorithms work and what are the do's and don'ts and how you should clean your data properly, etc. So if you are looking for good content in this area, then I can definitely recommend his content. But I agree, there is it's hard to find good quality content among the sea of randomness.
Yeah.
Yeah, and this is kind of, yeah, and especially given how the Google algorithms work. So Google bots are mostly occupied with keywords. So it's like they cannot really objectively assess the value of your content. They just look at the keywords. They are like kind of not very intelligent, you know. They are looking at the repetitive sentences and phrases on your website. So if you have a worse content but better SEO expert, then you will be positioned higher and you will be more visible.
It's funny because we see the same trend in resumes and people who apply to jobs, right? So people put these keywords in like Python or Scala, and it definitely gets them more interviews and callbacks. And I think, you know, it's interesting because it's kind of this tragedy of the commons, because every time an employer kind of changes how they do their interviews or how they do their recruitment, the whole market adjusts to kind of match that. And so it's kind of like the Red Queen hypothesis, where you have to keep moving just to stay in the same place. So yeah.
Yeah, it's
connections everywhere.
We fight for like kind of finite resources, right? So it's a bit of a like survival game. It's like
a little bit, yeah.
Environment. We just organisms that try to survive. I mean survive. You know, like in today's conditions, it's like not really you know, a fight for life and death anymore, but more, you know, but still there are not enough seats for everyone. Like there are like just only as many positions that are the most desired ones, and there's always more candidates per position than seats. So it's a form of a game. I agree with that. And yeah, and sometimes actually I have to admit that I still apply for jobs sometimes, and mostly because I want to train my own skills in terms of passing interviews, and not because I want a job. It's just a part of my of my own professional training to how to advise people with careers. So I have interviews sometimes. Like I had one last week, and yeah, and I kind of get skilled in these, like especially corporate talks during interviews. But yeah, it's a game. You have to kind of learn some phrases and learn, you know, which of the questions, let's say, are the progressive questions that can get you into the company, because you can actually shine when you answer these questions, and which of the questions are pure elimination questions. And it's more important what you don't say than what you say. It's just about not saying anything stupid, because the only purpose of the question is to eliminate unnecessary candidates. So you have to kind of learn this language, like which questions are actually what type and how to answer the problematic ones. And it's a kind of a game, and it's a like language that you have to use. It's a yeah, but yeah.
I might phrase it a little bit differently, and maybe not say it's a game as much as it's a skill. That there are people who are really good at interviewing, who are great employees, and there are people who are really good at interviewing who are going to not be great employees. And then there are just a ton of people who are terrible at interviewing but would be great employees. And so trying to make that transition into at least being able to do a good interview, I think, is probably an important skill people need to work on.
Yeah.
Especially coming out of academia.
And you mentioned before that you also took part in recruitment process for your employer.
Yeah.
And so I'm very curious about what is your personal strategy
for hiring people, and what are your principles, and what is your approach?
Yeah. Wow. Okay. So let's see. So I'll just give you a high level overview of the process. So what we do is we have, every time we open up a rec, we'll have maybe, I don't know, 200 to 2,000 people apply. And so we'll screen a lot of them out based on resume right away. Probably 50% get just screened out because they've no, coding experience, or they're coming from like they like write on their resume like that they hate bosses or something, like silly things that you probably shouldn't do. And then we'll take them, and the next step would be a hacker rank assessment. Now, I try to use that tool as a pass-fail. And so it's not about finding out who's going to be the best employee or the worst employee. It's about just ensuring that they have the day one skills that we need to be able to do the job. And we're not going to have to teach them how to do SQL joins or where conditions or like a little bit of Python. Like they actually have all the skills that they said that they do on their resume. And then we move into, I try to do panel interviews where everybody can veto. So maybe not panel interviews, that's not exactly what happens, but we'll have a bunch of different interviewers have their own specific time, and everybody has veto power over a candidate. But then, unless somebody vetoes the candidate, we try to find alignment between everybody, and it's a mix of technical and soft skills. And so we'll ask specific people to focus on different things. But who I try to hire are generally people who have the basic skills, and then also have intellectual curiosity, emotional stability, and just they're willing, they're smart enough to kind of handle some of the logic problems that we'll present to them, either in the hacker rank or on like a Zoom interview. But I'm not so concerned with someone's, like if somebody comes from pure software engineering or comes from the science side and had a good handle of R or Python or SQL from the science side, I don't really care. I don't need somebody who's going to be a true senior level, data scientist to come into the organization. I need somebody who within 3 to 6 months is going to start adding value and will continue to add value after that. And that's kind of for one level. Most of our employees are going to come in at that entry level. And by entry level, I mean people who have masters and PhDs and maybe a year of work experience, which is a terrible thing for the job market, but that's considered entry level, but it's where we are. Then for higher levels, and this is something that is often lost on, I think, a lot of younger data scientists and a lot of younger people coming out of academia, is that they see that they can move jobs every 18 months and take a 20% raise. And they do that for a couple cycles, and by the time they're on their fourth job, they are making a lot more money than they started with, but they also have never accomplished anything because they never stayed anywhere long enough to not only like learn the local systems, but also see a project through to deployment, right? Or at least one. Usually it's nothing. They might have a couple like smaller projects, but nothing big, nothing in the huge amounts of revenue. And so what I would suggest to people who are starting their career is to find some place, if after 18 months it's not working out and you don't think you're going to add value there, then definitely move on. But if things are going well, even if you could take a big raise to go somewhere else, stay for long enough to be able to add real value. Because when you do that, when you add the real value, then you really increase your, worth on the open market. And so there are a lot of people out there that have made their entire careers off one or two big projects. And, as a PhD or somebody coming out of a master's, that's where I think people really want to be is, you can definitely handle one or two big projects and become a very senior leader. So don't leave before you get any of those under your belt.
Yeah, very, very well said. And I think actually I was recently going through biographies of the most successful managers of today, managers in IT industry, including people like Marissa Mayer and what's his name, Tim Cook, and many others. So actually, when you look at their biography, let's say Marissa Mayer's biography, her biography is not that she was working in Google between 1999 and 2010, whatever. It's that, yes, she entered Google at some point, but then she took part in designing Google Ads, Google Doodle, this, and there is a list of important projects that today are very successful, and that she managed, or she was involved as a programmer, because she's also an excellent programmer. So she was actually doing hands-on work developing these products, and so she was there when it was deployed and until the end, and then she was moving to the next one. And she has a long list of products and services that are like world famous and in public use today. And that was her, this is her CV. It's not positions, it's the projects that she was creating. And this is what should be your like list of achievements as a professional, the projects that you were either co-creating or contributing to, and not just the list of positions. Is I totally agree. And I think this mentality should change, because I think there is a misconception, and if you want to get really far, then you should have successful projects in your portfolio. I agree.
Yeah, and I really want to kind of hone in on that, because there are two things that you mentioned that I think are worth exploring. The first is that if you leave the project before it deploys, someone else is going to get the credit, and people just don't realize that, and it's the way it goes. Then the second thing is that you're absolutely right. No one cares. Titles, especially in tech, are completely meaningless and mostly made up. There are lead data scientists who have hundreds of employees under them. There are directors that have hundreds. There are directors that have two. There are senior data scientist managers who have teams of 50 or no one at all. And so the position title doesn't matter at all. People look at things like, what have you accomplished, the number of people you've managed, the number of, and the projects don't necessarily have to be just products. They can be hiring out teams, they can be training teams, or maybe your project is retention or internal things that never go out to a consumer, but you help the company you're working for, optimize sales pitches or something. There are a lot of options out there.
There is a lot of debate right now what the differences between data science and machine learning engineering actually are, and if data scientists are redundant or not, and also what is the future, like how these jobs will look in the future in 5-10 years, what will be the real demand. If you are a young professional today who is interested in getting into data science or machine learning, what are the directions in which you might be interested in that have the most potential to to give you a kind of, I wouldn't say predictable career path, because you cannot really predict anything today, but the most options that you can be relatively feeling safe that in 10 years you won't be replaced by a machine. So you will have at least until early retirement, you might be safely assuming that you will not be out of the market. So how would you approach this if you were just going to get to your first ever class in programming? What would you choose, and how would you start a career today?
Okay, wow, there's a lot of questions in there. So I'm gonna kind of take these in order. So machine learning engineer versus data scientist. Again, I think titles don't really matter. What I do think and labels can be useful in some circumstances. So, if we're talking about the data scientist who builds machine learning algorithms and has a data engineer feed them the data, and all they do is build the models using open source tools like scikit-learn or H2O, whatever. I do think that job is in danger of becoming obsolete, or at least far less compensated than it is currently. Kind of like a gold rush in California in the 1800s, the people who made the real money were the ones selling the tools. So, H2O, Anaconda, the companies that are selling the tools are the ones who are going to make real money. Data Robot, Google, Auto, ML, all that stuff. And so right now we've been on a wave where 10 years ago, if you were going to build a neural net, you had to mostly write the code for the neural net from scratch, right? You were building your own loss functions, you were building, everything. 5 years ago, you get the open source packages, but all the tools and metrics were, you had to build yourself. And now those packages are so advanced that it's very easy to take people with very little experience and teach them about, teach them to run XGBoost or LightGBM or whatever. And so if I were going into data science now, and really even if how I live now is I try to focus on the hard problems that no one else wants to solve, but that need to be solved. And those kind of things aren't going to go away, right? So in data science or whatever this field is, the science part is often overlooked, and that's the part that isn't going to go away. Like knowing how to design your experiments, knowing how to design your systems. If it's prescriptive, you're going to pass it off to, an analyst level position so they can run the model or do whatever. If it's something that requires real problem solving and is hard to do, I think that career is always safe and also well compensated, because there just aren't a lot of people out there who want to take it to that next level. And so I would think about things like if I was in school right now, I'd definitely take courses on big data, because those principles become even more and more important. Even when we've got fully managed Spark clusters and EMR and all that stuff, like just understanding the concepts behind how all of the big data services work, I think could be really useful. I definitely take courses on experimental design, probably some courses on ethics, because I think that's going to be a big thing over the next 10 years. Visualization can always be helpful, especially for younger people. I wouldn't necessarily go into a career in visualization, but being able to communicate your results is really important. And did I mention like taking some real science courses, not 1 and 200 level bio and chemistry or physics, but the ones where you're actually learning. I mean, maybe at the graduate level, it's 400 or 500 level course where you're reading scientific papers, understanding why they did what they did, and then breaking down what they could have done better. And on those literature reviews, understanding why they didn't do the thing that would have made their study better. Oftentimes that gets overlooked because people are like, oh, they should have done it X, Y, Z way. And really that would have cost millions of dollars and nobody was ever going to do that. So, if you can get a sense of what corners you can cut and what corners you can't, I think that can always help.
There are lots of calamities in the history of engineering and, for instance, spacecraft that you can read about that come from like lack of fundamental understanding of the laws of physics, and where like billions were spent on the mission, and then just one, like there was this famous story where this platform in the sea kind of got crashed because someone didn't triangulate the shape of the bottom of the platform properly and didn't understand how to do it, and then it all crashed, and yeah, like the petrol worth like billions was lost, and it's like
Right.
things like that. So indeed, this is for data scientists like probably Yeah, but this is like some people argue that this is exactly the reason, the difference between data science and machine learning engineering, that engineering requires knowing the data, and that's why it's actually in the long run it's better than just like pure data science.
It's funny. So if you look at the history, right? So the highest paying best job in 1985 was analyst. Like that was a person making $300,000 a year and a 40-hour work week, and there were, I don't know, a couple thousand in the whole country in the U.S. Then people started, who weren't operating at that same level, started becoming analysts, and so then the analysts changed their title and their business intelligence, right? They're BI people, and then the people who were not operating at that level. Mm-hmm. But had gotten the analyst title go after that. And then, we go through this whole thing and it becomes, data scientists or data analysts, then data scientists, then machine learning engineer. And, really you're using a label that will only last for a couple of years until the term changes again. In our world of people who use machine learning and statistics, I do think, regardless of title, there are different types of data science and machine learning engineers out there. And, in industry, so the three I see are the people who do the cutting edge research that build the tools. They're coming up with new types of neural nets and they're actually writing the source code for different algorithms. That's type one. The type two people are using those algorithms and tools to solve new problems, right? And the type three people are the ones who are using those tools to solve old problems and doing refreshes and things like that, right? Maybe they used machine learning for marketing at one company and they're going to bring it to a new company, that kind of thing. I think the money is, and the fun is in being a person who's in category 1 or 2, right? And as long as you're in that area, you're going to be okay, and that'll be fine because you'll have a lot of longevity there. The people who are just using the tools to solve the same problems that have already been solved, those ones are going to always be the
followers,
one step behind, maybe 2 steps behind, depending. And so I would say, try to, not everybody's going to become the type 1 making new algorithms person. That I think you need a lot of technical formal training in, but there's a lot of opportunity to be the type 2 person to take, machine learning and solve a new problem, or to find a much better way to solve a currently solved problem.
It's very important what you just said, and since so many researchers are watching this channel, then maybe like in my mind this is a parallel to research, because in research we also have these fundamental researchers who are working on new methods or new ideas, new concepts, new from mathematics to like I was working in neuroscience, so new methods to analyze data, versus the experimentalists, the applied researchers who are taking those methods, using them to trying to answer new questions. So I think there's just a parallel. So if you have a sweet tooth for experimental, like applied research, maybe type 2 is for you. Maybe if you're more of a fundamental researcher, then maybe you're a material for type 1. But
I don't know if I would break it down. I kind of disagree with you there, because there are a lot of people who do basic research who would not be good at type 1, right? So like, I think they're like, I'm thinking of a biologist who might be in the wet lab, who are doing like cancer research. I think it's gonna be a really hard transition to go from like cutting edge cancer research to being the person designing new algorithms.
I was just thinking with the assumption on my mind that you can program, if you that you already. I get it.
No, I got you now. That makes more sense. I was thinking broader, but absolutely. Yeah, there is a strong parallel then.
Yeah. Well, that's but I agree. I mean, you have to provide value, you have to be able to offer something new. It must be either the new business model, so
new application, or it has to be new method. That's like one or the other or both, but it has to be, you have to have some specific point at which you can provide something new, build a novelty. So that makes you special, I guess. I mean, this is obvious what I'm saying right now, but well, but it's also, you know, this is also tricky, because when you look into like how the typical job interviews look like, they have phases, right? So in phase 0, when you're admitted to the whole process, and you have to do with like external recruiter, or you have to do with like this recruiter within a company, but like let's say that it's a corporation, so like multiple levels, and this is like this recruiter of the first contact who is not directly related to your team. It's just, you know, the first level of selection. Then when you come to the interview, you have to kind of show that you are just, you know, as closely fitting the pattern that they want as possible. So you're nothing special, nothing extra. You just you know, admit to the requirements like as tightly as possible. But then once you're like proceed to the next round, so you're not eliminated because you don't stand out too much. You're not, you know, you fit into the frame that they want. Then once you get to the next level of recruitment, where you actually meet with the hiring manager who might work with you later, might even be your boss, then you have to show that you can give as much extra value as possible. And it's actually often the case that people want to stand out, they want to show that they can produce, they can give something new, something extra, that they actually are so much more than what is expected, but they show it like in the process too early and they are eliminated. It's actually quite common. It's a common problem, because
Yeah.
the recruiter of the first contact, they only have a list of requirements, and they only look for, you know, they only check the marks. So this is actually tricky. You have to provide value. You have to prove it to the employer that you can give extra quality, but you have to know when to use this card. So
Yeah, absolutely. And I think it also really depends on what level of job you're applying for, right? So I think, and I talk about this a lot. One of the areas that's probably hardest for a lot of academics in the transition to industry is that you are again going from being a big fish in a small pond to, and you know, even when you're a graduate student, you might not feel like a big fish because there are all these, you know, tenured chairs and professors around who are, you know, brilliant. But you know, when you're trying to get that entry level job, I don't know if it makes sense to try to shine and show in the interview like how great you're going to be, because a lot of what the recruiters are looking for beyond that checklist of like, can you write code in Python and do you know this and that, is, are you going to be easy to work with? And so if you come off as egotistical or self-important, I think it'd be really difficult to get through to that next round where you can really show how great you are. And even then, like, you know, take that first job out of grad school and try to learn as much as possible and adapt to the things that you didn't have to adapt to in academia, you know, especially around the soft side of things and what people actually care about. And then, you know, after 18 months or 2 or 3 years, whatever it is, then try to go for that big jump, because like you're not going to get, nobody's going to hire a recently minted PhD for a principal data scientist position. And if you do get that job, unless you had industry experience going into your PhD, it's very likely that you're not actually working as a principal data scientist. You're, you know, it's just an inflated title like VP or
you
whatever.
might be the only data scientist that makes you principal.
Yeah, exactly.
Yeah.
Which again could be a great position in a startup, but also, you know, I would say that there's an opportunity to learn a lot. And obviously, you know, my advice is kind of geared towards people who have a similar pathway to me, coming from, you know, applied mathematics, PhDs, not, you know, people who come out of, you know, like Stanford physics or machine learning or comp sci or something, like maybe they can go on a different pathway, but for most of us, it's a little bit different.
Right, but actually it also makes me smile how, in small companies, everyone is the head of the department, this like, because like in academia, like it's just, you are a 30-year-old professional with a few years of experience and you're still like PhD candidate, it's like, doesn't sound so pompatic, and then in these like companies, like sometimes there are 5 people and they all have like position titles that are like 10 words long, and everyone is like the principal director of department,
Yep.
blah blah, and it's just funny. Like
it is, and you see the same thing at people who go into banks and finance. Like everybody's a VP, and it does, but nobody cares, right? Like you don't. Like if somebody applies to one of my positions with a VP title, I'm not going to reconsider them and be like, oh, I should make them a senior manager or something. Like it's whether or not you have the skills for the job.
Right. Yeah, well, I think I couldn't just feel serious about it if I had a position like this, but I get the point. I mean, also like when you like it maybe gives people more motivation and definitely looks better at their LinkedIn profile. So if you can give them that value for free as an employer, why not to give it? Like I would also do the same. If I had employees, I would just give them the best position titles they can have. Yeah, as long as it's not the owner, it's fine.
Yeah, I don't know if I think from a management perspective, I try not to do that because I want to match up people's jobs with their title in a way that's realistic, right? Because it's not really fair to ask somebody who's operating at a VP level to take a director title in the same way it's not really fair to ask somebody to take a director title when they're operating as a junior data scientist, because it's just setting them up for failure. I mean, it's one thing we see all the time, is people get these titles and then they go on Glassdoor and they're like, oh, well, I'm a senior data scientist. I should be making 40% more compared to all the other senior data scientists in New York, except that like those people with that title at other companies tend to be much more senior, right? And so you're just setting up the employees for poor morale because they're comparing themselves to people with 20 years of experience.
Right.
Yeah.
Well, if I can say something about it, I have to say that this is one thing I like about business development. If you have a company, nobody cares how many years you spend in the business. Like when the client comes, they want to have a job done. So, because I also, I started my company 2 years ago, and I do like workshops, trainings, like public talks, all kind of like services for researchers at the moment, but I'm also planning to launch services for companies, and seriously, and there are other people who also I know are very good as well, like good at what they do, but they are in the same space for 10 years and longer. And if I feel I have content that is the same good, I charge the same. I'm like, I will not charge like half just because I'm here for 2 years. It matters how much I can do and what is the value of the content. Doesn't matter how many years I was here, up to this point. And the clients respect that. They want the value and they pay for that. They don't pay for how many years you were doing the job. And that's what I love about having your own company, that it actually matters. You have to sweat, like how much you sweat and how much you can give, that matters. Doesn't matter how old you are or how many years you were around. And this is also one thing that kind of keeps me away, like from entering a corporate world as an employee. I never even had like that attraction to do it, because I know a bit that, it's a bit of a, you have to prove yourself also being in a field, and being in a field is also valued. So I would have to build up to something for like 10 or 20 years to be able to say, hey, I'm I can do it best in my field because I've built this, portfolio of projects and positions, and this is, I established some authority. And if you Yeah, and in business development, it just time passes by differently. It's actually different dynamics. So it's all about, yeah, it's all about how much your client values your work. That's, you know, how much you can give. And so it's a, yeah, it's a different, I mean, nothing is wrong with either of these. I'm just saying that they're different.
Mm-hmm.
And I actually like the entrepreneurial way more, but it's just my feeling. But of course, there are pros and cons either way. Yeah,
Yeah.
just saying.
Yeah, absolutely. Yeah, it can be challenging to prove yourself, especially coming out of academia, where depending on your employer's experience with academia, they may be thinking of people who have masters and PhDs as people who did an extended undergrad and like didn't want to enter the job market, or which I mean, at least for my own experience, is not at all what graduate school was. Um, and so you can come out with like this when you enter the job market, it can be a little jarring because people start treating you like, oh, you just graduated from college, even though you're, you know, maybe in your late 20s or early 30s, and you have been doing research for, you know, 5, 6, 7, 8, 9, 10 years. And so that can be definitely challenging, and it is an uphill battle. The only thing I'll say is that if you're at a good company like Verisk, like it takes, you know, maybe 18 months for people to kind of get the message and understand who you are and for you to build that reputation. But after that, it starts to really fall into place pretty well. And so there can be that opportunity. It doesn't take 20 years to build a reputation for people to respect you. It might take 2 years though. And even then, you know, probably some people could do it faster than that. So.
Okay. All right. I think we'll have to slowly wrap up, although I'm very feeling unhappy about it. I'd like to talk to you more, but maybe some other time, you know, there will be other occasions maybe to talk on this channel. But let me still ask you one like question that I often ask. If there is anything in your career up to this point that, well, if you had a chance, you would do differently. If you could turn back time 5 years, what would you do differently with your career?
I don't know. I don't know if I would do much differently. Thing I wish I had done earlier was, and this actually, Verisk has helped with this quite a bit. So I've got some really great people I work with at Verisk, and they also do a lot of support of like employee development through these kind of official courses that they run through Harvard Business School. And I think some of the things I learned in those courses, I wish I had known before, like right when I started. Those should have been like day one classes. And it took a little bit of time to learn. And that might have been something that I would change. But, you know, types of things that you learn there are that, you know, when you're in academia, the most important thing is publications and grants, right? That's all that matters. That is success, right? And when you're in a company, what's most important is not your own success, but the success of the company and helping other people. And, you know, everybody says that, but I think a lot of leaders also look for those qualities and value those qualities in other people. And I don't think when I came out of academia that I fully understood how important it was to help other people, and how that was much like their success is much more important than my own success. And that's the big thing, right? Like the whole management structure isn't designed around some system of like gates where like each person up is just, you know, in charge. It's designed around who is going to motivate people, who is going to help them do their work and get things accomplished. And these are very different skills than what we might value in academia. And I wish I had known a lot of those types of things coming in, or at least quickly after I started, because I think it would have made the first couple of years a little bit easier.
And I think we still have that reflex, right? We have that natural reaction after so many years working in academia. We have that like survival like reaction that we have to first and foremost build our own CV, and this is like, it's hard to change the like mindset day one, so it takes time for sure, but very important what you've just said, indeed. Okay, great. Thank you so much, Caolan, for all this great information and all your insights. It was great talking to you. And for all of you guys who would like to get more of this type of content, please subscribe to this channel and of course leave us some thumbs up. And if you have any questions for Caolan, then please contact him through LinkedIn or post your questions below. We will answer each one of them. So you're welcome. We're waiting for your questions. And thank you so much for accepting our invitation and for being with us today.
Thank you for having me. This was great. And please let me know about any future panel discussions.
For sure. Yeah, I think panel discussions are super nice. I think I definitely cast some. I think it's a good idea. Yeah. Okay, perfect. Thank you so much, guys, for watching, and till next time.